Hi, I'm Carl Franklin. In this episode of Blazor Train, we're going to turbocharge our remote access by using gRPC. gRPC is a standard that exists outside of .NET, outside of Microsoft. Fortunately, there are some great tools for using gRPC with .NET, and that, my friends, is like turning the old iron horse into a bullet train. Yes, there are limitations. Yes, you have to define your models using a completely different language, but how much performance can you gain from using gRPC over the standard API controller model? Well, the answer to that question is coming up right now, right here on Blazor Train!
So everything I'm going to show you right here and the code of the finished project is right here in my repo at carlfranklin/Blazor gRPC demo. So this demo, we're going to compare the performance of WebAPI versus gRPC by downloading 5,000 model records with each technology. Now, this isn't something that I'm saying you should do architecturally, but we need some sort of way to compare when we're downloading a lot of data, or accessing a lot of data through an API. There's a link there for the streaming demo that I did comparing SignalR, WebAPI, and gRPC, and also talking about streaming and what that is. So gRPC was started at Google, but it does not stand for Google Remote Procedure Calls. It's a recursive acronym that stands for gRPC Remote Procedure Calls. So that's what they say. It's a standard that exists outside of .NET and even outside of Microsoft. It was developed as an efficient means of transporting messages between microservices, but you can use it for any kind of peer-to-peer communication in applications. So there's a few things to unpack here. First of all, there's a protocol called protobuf, and there's a language that you can use to express messages and services that are sent with protocol buffers, or protobuf, and that language is called proto. Each platform has to implement its own code generator to translate those messages and services into platform-specific implementations that use the protobuf binary protocol. And the result is extremely fast cross-platform communication, and cross-platform is an understatement. Everything supports gRPC. Now, gRPC requires HTTP2, which this statement is a little bit old. It's not directly exposed by browsers. Some of the browsers are implementing it. Azure is implementing it. But as of this writing anyway, we had to use gRPC Web, which is an HTTP-based implementation of gRPC. Long story short, gRPC Web goes over port 80, so it's more accessible and goes in more places. So you can read all about that here, but just know that we're using gRPC Web in this demo. So I'm going to create a new Blazor WebAssembly app project in Visual Studio, and we're going to call it Blazor gRPC demo. Now you got to make sure this is checked off. ASP.NET Core hosted. We want a hosted project. And if you're not familiar with the layout of a hosted WebAssembly app, you have a server, an ASP.NET Core web server that hosts the client. There's the client at the top. And then you also have a shared project where models can go. And that's the first thing we're going to do is we're going to add a person model to the shared project. So you can see I've got an ID, a first name, a last name, a bio, and a photo URL. Next thing I need to do is add some data to the server project. That's this right here, people.json. You can get that at the repo. But I'm just going to copy it in and make sure it's in the root of the server project. So this file contains 5,000 bogus person records. And we're not actually going to be showing this generic person PNG. It's just there. So let's configure the server first. We're going to add a data folder, and we're going to add a class called Persons Manager. And quite simply, this exposes a list of person called people. And in the constructor, we're loading that file, that JSON file, into a string and then deserializing that into a list of person. So now to the controllers folder, I'm going to add a class called persons controller. This is obviously to test the API method. So in the constructor, we're injecting a persons manager. We have a get all. And then we also have this get by ID, which if we pass in an ID, which will be between 1 and 5,000, we're going to return that person in the people collection where that ID matches. So to add that to our services collection, we need to go to Program CS, and right here somewhere, we'll add that as a singleton, persons manager. That means one instance shared among all users. All right, let's configure the client. We're going to add a services folder, and to that, we're going to add a class called API service. So now the API service is going to be used on the client to make the call into the server, and it just wraps all that HTTP client code. We have our already configured HTTP client because right here, the base address of the HTTP client that's added is already set to the host environment, whatever that is. So get all is async, returns a list of person. We're using that HTTP client to get persons, ensuring a 200 status. We pull out the response body, we deserialize that and return it. You might want to put a breakpoint here if you're debugging and you get an exception. Get person ID is pretty similar, except that the URL is going to be person/ID/getById. And maybe we'll put a breakpoint here too. So we need to add API service to our services in Program CS in the client. We can do that right here. Builder.services.addScoped API service. Okay, now we need to add a couple @using statements to imports Razor, _imports Razor. And now we'll hijack the index page, replace that with what's in the repo. So line 2, I'm injecting the API service. I have a button that says test API. I have a string API result that I'm showing below the button. I've got a list of person called people, and in the API button clicked handler, which happens when I click the button, setting that API result to loading. Now, if I want to share it immediately, I can call await invoke async state has changed, and that will cause the page to re-render. And now I'm timing everything. So I set the start time to the current time, and then I call await API service get all. That returns people, right? And if people is not null, then I calculate the elapsed time by subtracting the start time from the current time. And my API result says people count, which should be 5,000 records, returned via API in elapsed.total milliseconds. Let's try it. All right, I'll click the button. Loading. 2 seconds. Okay, now remember, this is all on the same machine. But even though it's all on the same machine, in order to get the true test, you need to do it again because the first time everything compiles. So just a little bit faster, 1.7 seconds. And if you keep doing this, it's probably going to still be around 1.7 seconds. So now we're going to see if we can beat that number using gRPC instead of JSON over HTTP. So you need a couple of NuGet packages. I'll make it easy for you. Let's go down to shared and we'll add the packages right here. So you need Google Protobuf, gRPC Net Client, and gRPC Tools. Might be easier for you to just copy this item group out of the repo and then go update your NuGet packages to get the latest version. All right, let's do the same thing with the server project. I'm going to add 2 packages here, gRPC.ASP.NET Core and gRPC.ASP.NET Core.web. All right, let's add our gRPC packages to the client. SystemNet, HTTP JSON, and gRPC.NET.Client.web. All right, now I'm moving this up because we're going to do something really strange. I'm going to exclude person CS from the project. Right click, exclude from project. It is no longer there. Yes, I know weather forecast is there too. And to the shared project, we're going to add a proto file. So new item, and it's going to be called people.proto. Now, Visual Studio knows about proto files. I'll go over all of this stuff in a minute, but let's just take a look at the properties here. The build action has to be set to protobuf compiler. Also, make sure that gRPC stub classes is set to client and server. Everything else should be okay. Compile protobuf, yes. Class access public. Okay. Now, if you want to check this, save everything and go into the shared project, and then you can see protobuf include people.proto. I'm not sure why this is here. Item group remove equals people.proto. I'm going to delete that. All right, let's talk about that people proto file. Starting with this message person. Now, it kind of looks like a class, but what the proto language is trying to do here is trying to make what is essentially a class in C# as generic as possible. So it's trying to avoid words like class and struct and all of that stuff. It's a message. This is just a payload for sending this information from one place to another. So we have some familiar types. These aren't C# types. These are prototypes, protobuf types, whatever. So int32 and string are the only types that we have here. So a couple of things you should notice. All of the fields are camel cased, and each field has an ordinal, 1, 2, 3, 4, 5. That's because the protobuf protocol does binary serialization. There are no names, unlike JSON, which is kind of readable and full of names. This is a binary format. And so this is how we map these field names to positions in the data stream. It's that simple. All right, let's go up to service people. So this is essentially going to be a back-end service. Think of this analogous to your API controller. So you're only calling it people because the rest of it is going to be put in there, people service and people client for the generated code on the client, right? So then we have RPC, which means this is a remote procedure call. It's called getAll, and it takes this getAllPeople request, which is weird because the message for getAllPeople request has nothing in it. It has no fields. It doesn't matter. Every RPC call in gRPC has exactly one type that gets sent and one type that gets returned. Now, the people reply is a list of person, and that's where this comes in, repeated. Okay? It's not an array. It's not a list. It's not a collection. It's a repeated message. So this is basically saying, for you C# developers, this is going to return a list of person, people. So the second one here, get person by ID, takes a get person by ID request, which has the ID, and returns a single person, which again is our simple message. Okay, you getting it? So this proto file is going to be turned into a person class for the model, and it will also give us a base class for a server implementation, And on the client side, it's going to give us a client. All right, now I'm going to build the solution just to make sure everybody's happy with this proto file and we can access it everywhere. See, even though we don't have a person class defined by us in C#, it's still there. It's just lurking in the background. All right, so let's implement the service in the server project. So in the data folder, I'm going to add a class called people service. So looky here. It's a public class that implements people.peopleBase, right? So we already have a base class for this service generated that we can now customize. Now, remember, this code isn't generated. This is code that I wrote to implement the people service. So I can do whatever I want here with the constructor. I'm injecting my persons manager. So let's look at get all. So I'm overriding get all. It's already there in the base class, but it's a virtual method. So all I have to do is override it. So there's my people request, and there's a server call context, which is cool because I can get some context around the service call. So here's my new people reply, and to that reply.people property, which is a repeated field of person, I can call add range and add persons manager people. And then I'm returning task from result. So for the get person by ID, it's the same idea. Here's our request. We're returning a person going into my people manager, and I'm pulling out people where that ID is the same. That code should look familiar because that's exactly what we did in the API. So to use gRPC on the server, we need to do a little configuration. So let's go to program and let's add this line, builder.services.add gRPC. And then just below use routing, we're going to add these two, app.use gRPC web and map gRPC service people service, enabling gRPC web. We have to call map gRPC service for every service that we want to use. All right, let's configure the client. I'm going to go to the client program CS, and we're going to add the following. I'm adding people client to the services collection as a singleton, but I'm doing that with this little anonymous method. Here I'm configuring an HTTP client. I'm getting the base URI from the navigation manager, base URI, and then I'm creating a channel for that address with the options, passing the HTTP client. Then I'm creating a new people client from that channel. So that people client is now configured with everything that I need to communicate with the server. So let's add to our index. I'm going to keep the same API code, but I'm going to add some more stuff. So here's my test of gRPC. I've got a gRPC result here. gRPC button clicked. And then I've got the button to get a random person. Here's my person result. API button clicked is the same. gRPC button clicked does the same thing with timing, but now instead of using the HTTP client, I'm going to use the people client. And yes, people client is injected. And then getting the random person clicked, I'm not timing it, but I'm basically creating a random number between 1 and 5,000, passing that in and just retrieving it. All right, let's give it a shot. All right, our API shouldn't have changed. It should be about 2 seconds the first time, about 1.7 seconds the next time. gRPC the first time. Whoa, 494 milliseconds. How about the second time? 292 milliseconds. That's almost instant. And random. No problem. I wonder if gRPC can get any faster. It's still hovering around 250 milliseconds. Now, this wasn't enough. I wanted to show how fast this would be if I published the server to Azure. And I didn't do that for .NET 7, but I do have the .NET 5 results. So let's look back to April 2021 and see what the results were.
Now, this wasn't enough. I wanted to see how this performed when published to an Azure web service. So I did that. And here it is, Blazor gRPC demo server.azurewebsites.net. Now, don't worry, I took it down. I don't want to incur a lot of charges, but let's just try this from scratch. Okay, well, first of all, the API performs better when it's in Azure than when it does on my machine. That's interesting. 975 the first time, 862, 793. All right, what's gRPC? 391, 277, 278. So it's still performing more than twice as fast. And of course, getting random person works just fine. So this is by no means an extended tutorial on gRPC, but what I hope it does do is motivate you to learn gRPC and use it where it makes sense. Back to you in the studio, Carl. You know, gRPC performance is great, but there are many unanswered questions. Can I just turn my existing API controllers into gRPC services using some kind of wizard? Do I really have to give up my existing classes? And what about partial classes? It all seems so messy. Well, you're right about that last bit. Perhaps we'll continue to see great tooling coming out of Microsoft and the .NET community. Time will tell. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a trail.